And here we go. All right, so a little bit about me. I'm an entrepreneur with a curiosity portfolio. I run a career accelerator for early in career folks called the Breakout Space. I also help high skill immigrants learn about merit based immigration in the United States, AB1A. And I previously held product roles at Amazon, Microsoft, and Bank of America. I went to grad school at Carnegie Mellon, and you can find me online, my writings at Substack, and my Twitter and LinkedIn. So of the 5-6 years that I worked in products so far, a large majority of it was working with developer products. I started off my career as a developer myself. And in both the roles at Microsoft and Amazon, I learned a lot about developer experience, dev platforms, whatnot. At Microsoft, I owned this platform called Microsoft Identity Platform. And my job was to make identity simple, easy, and secure, easy, and simple for developers. And most recently at Amazon, my role involved building a dev platform and API for a confidential Blue Sky project. Here's a rough outline for today's talk. It's roughly divided into 3 phases. First one is before you build an API. Second one is during. And the third one is what happens after you've shipped. The top 3 takeaways that you can assume from today's session is first one is the order of difficulty. APIs are unique in a sense that of launching, maintaining, and deprecating, the easiest part is launching an API, followed by maintaining, and followed by deprecating. It's unlike most of the product thinking that product managers are fed into, thinking like you need to fail fast, experiment, launch quickly. APIs are actually quite opposite. You have to think about end of life and deprecation, or what happens if your product one day no longer exists. What will be the impact to your customers? It's not a UI change or a feature change where you can quickly roll back. So intentionality is super important from the get-go. And also thinking about all the scenarios and worlds where your product may not exist. Your table stakes when it comes to API development is security, documentation, and communication. Security because you want to make sure that your data and your customers' data is secure and you're not compromising on it. The second one is documentation, because the only way developers are going to use your product, adopt, experiment with it is by following the guides and tutorials and documents that you publish. And the third one is communication, which is you will introduce changes and your APIs will evolve over time. Plus, you would also seek feedback from your existing developer community. So having a way for two-way communication with your audience and customers is super important. The third takeaway is your primary customers who are developers are loud. They are super active on Twitter. They are active on developer communities. So any changes, good or bad, you are going to get a lot of noise and a lot of public visibility on it. They are also community driven, where they like to hang out in various forums, communities, and they tend to learn from each other. So you have to keep that in mind when you're building or shipping any sort of API or developer product. So this talk assumes no knowledge about APIs or developers. So this might be repetitive for some of you, but hang on until we get to the good stuff. So in very simple terms, APIs is a communication standard for software systems to interact with each other. So imagine if we all were in a room where we all spoke different languages. Let's say I'm speaking Hindi, somebody else is speaking English, and then somebody else can only speak French. Now, how do we all communicate with each other? That is the problem APIs solve for software systems, where system 1 might be on technology 1, system 2 might be completely outside of its universe on technology 2, system 3 might be completely different as well. So APIs helps all of these systems to talk to each other and interact. They are also meant to perform really specific tasks and are centered around a resource. So for example, you can use an API to fetch all the users using an app. They're centered around resource, meaning anytime you're using an API, you are either going to do CRUD operations on a resource, meaning you'll either create, read, update, or delete. And APIs, because they're also standardized protocol for communication, they are programming language agnostic, especially if they're exposed via HTTP and returns in a language neutral format, either JSON or XML. They are centered around this question answer model, which is a request and response. So you can sort of think like a client is asking questions to its server or asking specific tasks to be performed to a server. So because I keep in mind standardization, anybody can talk to anyone. The request, the way questions are asked, or a specific action needs to be performed, there is a way to ask that request from client. And then similarly on server side, there is a standard format in which the server responds. Because of this standardization, APIs are useful and then helps various disparate systems talk to each other. There are three fundamental types of APIs. First one is an internal APIs or private API. These are APIs typically within the walls of a company. So if team 1 wants to talk to team 2, but those APIs are only available within the realms of that organization. Second one would be partner API, which are shared between 2 or more organizations. So for example, there's a partnership between AWS or Twilio. There might be some set of APIs that are only available to each party, but are not publicly available. So it helps different companies talk to each other in a much more private or shared private manner. The third one is open or public APIs. These are APIs available to all developers or just about anyone to use. They are reachable on the internet, anyone can use it. And they're often used to integrate or build third-party applications. These are the fundamental components of an API request and response. The first one is an endpoint. Think of it as a specific URL or an address, like an API address, to perform a specific action. For example, if I want to fetch all users, my endpoint might be api.example.com/version/users, which means give me a list of all users. Now, because I'm needing to perform a specific task on a resource, we tend to use HTTP methods. There are 4 popular types of these methods: get, post, put, delete. They are analogous to CRUD operations. The next thing here is parameters, where if you want to specify additional information or provide context to your request, you will use query parameters. So if you've ever noticed in a URL, sometimes there's like $Q equals to something, something. Those are called query parameters, and it helps you narrow down your request or provide more context. So for example, when I was getting a list of all users, what if I only wanted users in a particular country? Or if I wanted users who onboarded on a particular date, then I can sort of like specify a parameter saying, okay, country equals to this, or onboarding date equals to this. The next component of an API is a header. Header can be part of both request or response, which means it could be part of either the question or the answer. And they generally contain metadata or additional information, which can include content type, format, caching directives, or even warnings. In very simple terms, this is how a request looks like. The first portion here is the server URL. It will typically contain your base URL, your version, and then your resource path, so where your resource is located, followed by query parameters, wherein if you want to, let's say, provide additional context or filter down your results. Similarly, for response, because now the server is answering your question or responding to your particular question, it's going to give you a status code, which will tell you as a client or somebody who asked the question, what happened to that request. So generally, there could be 3 types. Either it's a 200, which means that everything went perfectly on both sides, or it could be in 400s. So not necessarily 400, but anything that starts with a 4. it means that there might be a problem on the client side. So somebody who's asking the question, and then, or it could be 500s, where there might be a problem on the server side. So that tells you, like, if you were to retry, what exactly went wrong. Then it could contain a response header, which includes additional information, and then a payload, which will include the answer to the question that you asked. This is the format that's followed for all APIs, no matter what it is designed for. This is just something very standard for each and every API. Now, you need to, before you ship APIs, because it's not something that you can do on a whim or just roll back. There are no undo buttons when it comes to public APIs. You have to be extremely intentional about building API, especially if you are building public APIs. So there are two broad categories of reasons. First one is system reasons, and the second one is business reasons. So for example, if you are a social media company and you want third-party developers to build apps on top of your platform, then you will need a way for them to build on top of the data that's already available on your platform. Without an API, it might become extremely hard for them to access, and you will have to manually onboard them one by one. So APIs offer you scalability in the sense that it helps you publish a way to communicate with your system, and it helps you standardize and follow standard protocols that makes your job in a very developer fashion, write once, read many, where you do the work once and then it can be used by multiple people or multiple customers. And the second one is interoperability. So you might want to interact with other systems, or your customers might be using different underlying technology. So APIs allows you to abstract all of that and have a standard way for third-party or first-party developers to build on top of your platform. When it comes to business reasons, it helps you monetize, and it helps you take the leap from just being a dev platform to an ecosystem. So with monetization, it could be either direct, where you are charging for your APIs, or it could be that your developers are building apps that are in turn helping your whole ecosystem grow. When I say it also helps you take a leap from platform to ecosystem, where if third-party developers start to build on your data and your platform, then it provides your customers a richer set of functionality, and hence growing the pie for everyone involved. It also helps your developers be part of this thriving community, where it comes a point where they can support each other while building on top of your platform. Now, when it comes to API design tenets, these are generally 5 good design tenets to think about before you launch. So APIs are always designed with a specific intent in mind. So think about what are the use cases that your customers might have. They are not just a mere exposure of your database. So it's not so that, let's say, you have a bunch of tables and you have relative relationships between those tables. It's not that you just expose that as is. You have to carefully think through what are the specific use cases your customers might have. And this sort of thinking also helps you ship in a way that there is reduced chances of API misuse. Then the second one is APIs are idempotent. I cover this in more detail in just a few slides. And then the third one here is that APIs leverage a developer's existing knowledge. So there is quite a bit of standardization that already exists. The more you bank upon existing brain muscle memory, the existing standard protocols, the more easier is it for you as well as your customers to build on top. So this can include semantics, terms, even like nouns used, or protocols and industry standards. Then the next thing is they are composable and consistent, which means that it's much better if your API does one thing and one thing well versus having one API do two things. So think of when you're shipping APIs that they're Lego blocks, where each Lego or each API has a specific purpose in mind, but then they can be stitched together to accomplish different things or more complicated tasks. Then the next thing is backwards compatibility. So when you are shipping an API, you can assume that it's going to evolve over time and it's not going to remain the same month over month or as your product matures. So you have to ensure that when you ship new stuff, new features or updates, you aren't breaking old stuff. Because imagine when you've already shipped, your customers have already built applications on top of that. When you are introducing breaking change to an existing API, then you're sort of asking your customers to also update their code base, which, depending on the size of your company, might not be a small task. Now, I just have a quick poll here. What do you think is harder, building new APIs or deprecating existing APIs? And you can use the chat box to just put A or B. And then Emma, you can sort of help me just get a sense of what people are saying here.
Yeah, absolutely. Give it just a minute. Seems like B is the most popular opinion. Somebody's saying the chat's disabled. I'll look into that as well. But we're getting a lot of B.
I sort of already answered that in the beginning. But yes, the answer is B. It's unique in a sense that deprecating existing APIs is much, much harder than building new APIs. So if your business is not at a stage where you need APIs, it might not be a bad idea to just not have any APIs versus just hurrying through it and then putting something out there. So in the next few slides, we're going to talk about API quirks. So why is deprecating harder than launching? So once you build an API and make it publicly available, you can assume that it practically lives on forever. So any API quirk, any substandard change will continue to live, and which also means that your dev team will now be responsible for maintaining that substandard features for almost for eternity. So across API updates, for API versions, many years, until you're able to finally deprecate or decommission it. So for a large customer or a large company, it can literally be forever or feel like forever, especially given the software cycles are so quick. So it's just much better if you are intentional about it. It's sort of measure twice, cut once type situation. And then you also sort of skip over all the technical debt, all the resources that you might have to deploy in the future just to maintain that feature. So what's wrong with rolling back, deprecating, or introducing changes? I think until now, it's sort of clear why it's sort of hard to just roll back or undo whatever you've done. It's because once it's out there, your existing customers have already, their systems are built around your quirks. So they think that if you have shipped something substandard, then they have already adopted it. They have built workarounds. They have found alternate ways to do the same thing. And they might have their existing businesses or functionality on top of your APIs. So if you suddenly say that, hey, you're going to introduce a breaking change, they are not going to be happy about it. And then going back to takeaway 3, developer community is extremely outspoken. So, and it is very hard to earn their trust again once you've broken it. So the TLDR is APIs are easy to build, hard to maintain, and hardest to deprecate. It might sound like a lot of repetition, but it's a save that I want to plant so that it's sort of in the back of your mind when you go and build your own products. API quirk number 2 is managing requirements. So this is one of the areas where your customer requirements and your business requirements may be at odds. And that happens a lot in APIs because as a company who's sitting on this wealth of information or data, you may not want to ship everything, but your customers may want a way to access your data in a much more faster manner. So this is like one of the areas where you have to be extremely intentional about your business use cases, as well as listening to your developer community, and and then thoughtfully shipping what you think might be a long standing or something that might stand the test of time. So you may have to think about what not to ship. So for example, if you believe that it's not right, it's not the right time to expose all of your customers data, then it might not be the right time for it, or it's not the right time to expose or make it very easy for someone to scrape your information or the wealth of information that's there on your website. It's not a bad idea to not ship that API. Or if you think like it's too soon to expose order information, let's say if you're an e-commerce company via an API, it's totally okay to have some functionality available as an API, but not others. So you sort of like think about the second and the third order effect and what will be the impact few years down the line. It is also a good idea to imagine the worst possible scenarios in pre-mortems. So right before you ship, you can sort of like do a collective exercise where you think about everything that can go wrong with this product, or what happens if you do this for X number of years and then suddenly stop doing it. And then because developers are outspoken and community driven, it's also a good idea to maintain a line of communication, a direct line of communication, and provide updates constantly, because it is inevitable that you will introduce changes that your customers won't be happy about, or you might be deprecating key functionality. And one way you can sort of help your customers is to be really transparent and clear about it. And if you have mechanisms to communicate with your developers on a much more direct basis, then it's not going to make their situation any better, but at least you get points for being transparent and giving them maybe enough heads up so that they can manage on their end. Here are a few recent examples from API work number 2. So all of you must, especially Reddit users might be knowing about this. So Reddit suddenly made huge pricing changes to its API. And Apollo, which is a leading well-known iOS app for Reddit, had to shut down overnight. And with LLMs, like companies are now much more protective about their data. And similarly, Twitter also stopped offering their free tier for developers and is now only offering a paid version, which led to lots of apps being broken overnight. So think about your business use cases as well. It's not just about what your customers are asking for or what developers need. It's also about, is this sustainable for your business? Is this the right time and the right thing to ship? The third API quirk is API changes cannot be siloed. You have dependency on other developer interfaces that also need to be taken into account. The first one is documentation. So if your documentation is about to do or execute a certain API in a certain way, and if you are introducing changes, then you will have to update your documents as well. And then sometimes, especially for large companies or bigger products, it's not just your documents. There are like other companies who are built on top of your product. And then you might have to take into account the time that they need to like bring their house in order when it comes to changes related to an API. The second thing is SDKs. If your product also comes with an SDK, anything that you're changing in your API may also impact your SDK. So you have to make sure that your API changes are also reflected in your SDK. And the third one is UI. So this is not the dashboard or the API playground that I'm talking about. Sometimes you will have UI that replicates the functionality of your API. So for example, if you have an API to create a payment link, you might as well, your customers might also be able to do that through the UI. So when you introduce changes, you have to ensure that there is parity between all of your developer interfaces and touch points so that your customers get a consistent experience throughout. If you've decided to launch an API, then there's two different types of API checklist. One is where you have standard protocols to follow. And the second is a checklist, which is going to be more custom, wherein you will have to build custom solutions in order to go through that. An API checklist is also a good practice to introduce in your company right before or while you're building a product. So it sets a standard for any changes that are introduced. It goes through that API checklist before it can make it to the production. So in terms of standard protocol, you have to ensure that there's security or authorization authentication. So for example, like if you have an API, you will need a way to identify the customer, and you will need to authorize the customer to access a certain API. You might have different tiers of permission where, let's say, customer 1 has access to A, B, and C, but customer B has access to D, E, and F. And you want to make sure that you have the right security practices in place so that the customers who are only authorized for a certain set of operations are authorized to do that and nothing else. And when it comes to APIs, the pro here is that you can automate a lot of the testing. So APIs allow for automated testing, which helps you scale and ship faster. The second one is data formats. You would need to agree upon a standard data format that your customers can read. Typically, it's either JSON or XML, and that there's standard error codes that you can bank upon to inform your client about whatever happened with that request. When it comes to custom changes, you will have your own versioning, you will have your own rate limiting. A good example, and then these are things that might sound very obvious, but it's quite possible that these aren't implemented or aren't available. So to give you an example for rate limiting, like imagine you have an authentication system where a customer logs in with the username password, and then they are presented with an OTP as a multi-factor authentication. If you're exposing this via an API, then what happens if one of your existing customer manages to just like brute force your OTP request? So typically OTPs are 4 or 5 character numbers. And if you don't have any rate limiting, they can literally go from 0 to 10,000 and then in a matter of seconds, and one of them will tend to work. So you have to make sure that you rate limit, depending on your API, you will rate limit the number of attempts that can happen in a set amount of time. Then you would need a test playground or sandbox environment. So developers typically need to learn and experiment on your platform. So if they are able to do that without impacting their production data or production services, then it helps them sweeten the learning curve and it helps them be more familiar with your platform. The next is monitoring and analytics. So you need to have a way to track usage and performance so that A, for your own product development, and B, so you understand that everything is working as expected and you can sort of either react quickly or preempt a change or an error in the future. The next one is documentation, which is extremely important when it comes to developer products, because it's the only way that they can sort of understand your system. And it also helps you reduce your support ticket if you provide more support upfront through robust documentation. And the next one here is feedback and communication. You would want to listen to your developers and have a way to get constant feedback. as well as share announcements with them. So it's very important to have two-way communication between your developers and yourself. Now, the next few section, we're going to talk about API best practices. So the first one is error management. So it's just blasphemy to fail silently when it comes to APIs. You have to handle errors gracefully and return the standard error codes. It helps your developers learn if there's anything unexpected that happens with the request. If you fail silently, then the developer or your customer will never know what went wrong, and it might be a long time until they understand what went wrong or why something stopped working suddenly. Failing silently, if you look at a developer product, it's sometimes like the top reason for most of the SEV ones, and you can sort of preempt that by being very intentional when it comes to handling errors gracefully. And then you're presented with standard error codes that you use for different scenarios. So it's a common language and people understand what needs to happen when they see that error code. The next one here is idempotency. It essentially means that no matter how many times a certain operation is done, it does not change the result. It's sort of like multiplying by zero. So if no matter how many times you multiply a number by zero, the answer is always zero. And the reason this is important for APIs is because within the software systems or computer systems, you are bound to get failures and errors, and you may have to retry. So having idempotent APIs helps you to safely retry without unintentionally performing the same operation multiple times. To give you an example, so post is the most custom of all of these. The rest, get, put, and delete are sort of automatic, where let's say if you're getting a list of users, you will always get a list of users and you're sort of not making any changes on the server side anyway. So get request would be idempotent. Then your put is updating the record. So let's say I'm asking for let's say for a certain user, their bank balance to be updated from X dollars to Y dollars. Then only the initial request will cause the change, and then subsequent operation should leave the state unaltered. And then delete, once you delete the record, then if you have multiple delete requests, that record won't be available to be deleted. For post, generally you would require on the client side to send a unique key that the server can understand, so that subsequent request with the same key would return the same result to the client. So you don't want to be in a situation where, let's say, I sent a post request, but then I retry it again, either because I got an error or because I wasn't sure if the previous operation happened. You don't want that request to happen twice when the client intended for it to happen once. So this is why idempotency is important, where if without this, you might be in a situation where your database or your records are getting updated without it being intentional or mistakenly. The next one is documentation. I think we all understand why documentation is important. The reasons on this slide deck are pretty standard and obvious, but the place where documentation also helps and is sort of underrated is it helps in building trust and credibility. It also helps with marketing and adoption. So while it's like extremely painful to maintain documentation and keep everything in parity, companies that do a good job at maintaining documentation, because key takeaway number 3, developers are outspoken. You do build a lot of trust, and there's sort of like this whole ripple effect and word of mouth where more developers start to trust your system, and it helps with it's sort of like marketing and adoption is almost like a byproduct where it helps you get new customers without spending marketing dollars upfront. But the thing for documentation is it's easier said than done. Like writing and maintaining documentation can be real bore, and it's not everyone's cup of tea. And it's sort of like the thing where, to be honest, like most people think of it as the tax that they have to pay once they've shipped their like glorious feature. So for you to like get ahead of that or manage that, you have to you have like most companies, the way they manage it is they hire for this role. So they will have content writers and content managers full time. And then in the absence of that, unless you make it part of someone's job description and the whole performance review, it is pretty much guaranteed that you will have stale documents. And then another good way to make sure that your documents are up to date is to make it part of your launch checklist. So a product doesn't get shipped unless the documents are ready to be updated. The next section here is about deprecation. So inevitably, you will deprecate your APIs. You can only do it gracefully. You cannot avoid it. So the way to do it gracefully is to make sure you give enough time and heads up and multiple reminders to your developers so they can sort of manage that with their own product and their own customers. Pre-mortem is a good exercise. Think about your angriest customers. Think about the worst headline you could get. What happens if your API is no longer available? Think about the second order effects. What would happen if this does not exist? Like imagine you have multiple customers and all of their code bases need to be updated. And they might have built entire businesses on top of certain APIs. Now, this last section is about launch strategy. So generally, when it comes to launching API products, you will do it in 3 stages. First one is a private beta, followed by a public beta, followed by general availability. So your private beta is a list of allow listed partners or customers who will be the first one to try out your product. Generally, they will come from your existing customers. Make sure you use this private beta time to deeply understand use cases, emphasize on testing and fine-tuning the API's functionality and performance. Use that time to start building up use cases and studies so that you can sort of use it when it comes to your general availability, and you can publish your existing customers' case study for more adoption and for other customers to understand the use cases. Throughout your beta phases and even beyond, once you have GA'd, you need to encourage your customers to provide feedback and make it easy for them to do so. So no matter where they are, like I have multiple ways to ask for feedback and multiple touch points and listen to the developer community. When it comes to public beta, a lot of people think like this phase is to experiment on customers. It's not. It is to build on top of what use cases you've already identified in private beta. No part of your beta experience should be about experimenting on your customers. It should be about validating your hypotheses and how you can build it in a way that APIs would stand the test of time. So this public beta is a phase where you will open it up to a broader set of audience. You will sort of do a promotional announcement through whatever interfaces or touch point you have. You will highlight key features and benefits. Some of it might be more available to you now that you have crossed the private beta stage. And then even in this category or phase, you will continue to gather feedback. The third stage here is general availability. This is where your API becomes public for good and people can access it no matter where they are. So there is generally no restrictions as to who can use your product. So when you go to GA, you would have already built on the basis of feedback you've received in private and public beta phases. You want to make sure that now you are available to a wider audience, that your API is built to scale and it's robust, secure, and ready for broader adoption. you have to ensure that you have comprehensive documentation with tutorials, guides to ensure a smooth integration process. You can even have goals set up so that you can measure your GA launch. For example, if it's a net new product, then your goal could be to, if you think about phases or type of customers, your goal could be to attract new customers. Your goal could be to grow your existing customer base or grow more use cases for your existing customers. And then you can also have a way to sort of a goal that's super specific. So for example, if you want to get your customers to use any of your APIs in the first 15 minutes. So for example, they come to your platform and then you have tutorials and guides, or even like boilerplate code or code samples that they can just download and run. So the lesser the learning curve, the more likely they're going to tolerate and sit through your system. So you might have goals around how quickly can someone onboard, especially in the beginning. And then because you are now in public or GA, you will also need to define your pricing model and pricing plans. You might have different tiers where you give, it could either be about the volume. So for example, like 10,000 requests per month is this tier, 20,000 is this tier, 1 million is this tier. It could also be about support. So priority support could be part of one tier, but regular support could be part of another. So you will have to determine your pricing based on your use cases. Sometimes people also, or companies also start with a free tier and then sort of introduce pricing at a later point in time. And then finally, you will have announcements, and this is more of a marketing thing where you will highlight your use cases. You'll talk about the product, what it does, what is a successful, you will highlight the successful completion of prior beta. You now have your private and public beta customers' use cases. So it might be a good idea to publish those studies, and that will sort of help your new set of customers visualize and understand the practical applications much better. And then finally, after you have shipped, you will have to take care of 5 main things. First is, just because you have shipped does not mean that your job is done. Your job sort of starts after you have shipped an API. So you will provide continued support. You will have feedback, two-way communication and community. You will need to have a mechanism to ensure you have up-to-date documentation. And then anytime you introduce new features or new updates, you want to make sure that your previous versions continue to work. In absence of that, you would have to have a deprecation plan and make sure you communicate it early to your customers. So this brings up to the entire life cycle of an API, where it's like premeditation as to why you need it. Is this the right time? What could go wrong? And then from there, once you've decided, it's pre-launch, launch, while you build, and after you've built. And with this, I want to open the floor for question answer. You can find me on Twitter, LinkedIn, Substack, and feel free to just raise your hand and ask a question or use the chat.
Thank you for the awesome presentation. This was really covered all of the details about building APIs and taking them all of the way from inception to launch. We do have a few questions that folks had submitted. So we can maybe get started with that until the questions trickle in through the Q&A capability.
Sounds good.
So I think the first one was around API development concepts and strategy. And the question was, hey, as a PM working on API technologies, how can you best contribute towards API success? And how do you align API development strategy with your company strategy overall?
Mm-hmm. So first is, what is your role as a PM when it comes to API development? So your role will be to think forward, think ahead. Like, is this the right API to ship? Make sure you evangelize the top 3 takeaways where there has to be premeditation and a lot of thought and intent behind what APIs are being shipped. Second, our APIs are intentful, which means that they do a specific task. So PMs would generally come up with a list of tasks that they would want a developer to do to build on top of their platform. And then third, I always say product is everyone's job. So you're, as a product manager, you're not working in a silo. So make sure like you involve your customers, you involve your partners, you involve your dev team to create a list of robust use cases and then the corresponding APIs for that. A lot of PMs also write API specs, which means that if you've seen the Swagger documentation where they'll define the methods, they'll define the base URL, they'll define the resource path, they'll define the query parameters. And then this is always also, of course, a collective effort as well. So all of that to say is that as a API PM, you have a lot pinned on your shoulder. And then the second part of the question was, how can you collate your API spec to your business strategy? So that goes to like one of the API best practices or quirks that I had mentioned, where your business requirement, your customer requirements may not always be the same. So it's much better to like not ship something if you think that it's not right for your business strategy versus to like have a backlash later on. And then obviously like this is also a good time to get feedback from your leadership and from your customers and to really understand their use cases. But business strategy first.
Yeah, thank you for that answer. The second question we had coming in was around API design and architecture. And the question here was, companies like Twilio, Stripe are popular for having very intuitive, easy to use APIs. What principles do you follow to make your APIs easy to use?
Mm-hmm. So a good rule of thumb is if you are able to read that get post, whatever it is, and understand what it could do, it's a good API design. So for example, like get users, it tells me intuitively that it's going to give me a list of users. If it's like get users question mark with a certain query parameter, it's very intuitive that it's going to filter on these things. So if you can read it in plain English, it's a good API.
Awesome. Thank you for this very simple explanation. That makes a lot of sense and aligns with my intuition of what a good API is. A follow-up question here around design and architecture. I think you touched a lot upon like versioning and the importance of versioning, the importance of not breaking past versions of the API. Mm-hmm. One of the questions we had related to that was, how do you actually practically do this? Like, are there any protocols or methods that folks can learn about that, you know, make this easy to manage? Because obviously we go through a lot of like iterative development, but at the same time want to make sure that we have backward compatibility for the APIs that were launched in the past.
So you might have to phase out previous versions. So for example, you are supporting V1, but you aren't introducing new features to V1. And one of the key things when you're shipping APIs is communication. So as long as you communicate to your dev community that there aren't going to be any more updates to this version, you sort of like have made their job way easier because you've managed their expectation. They aren't going to bank upon that version to build in the future. And then they get time to move from, let's say, V1 to V2 to V3.
Awesome. Makes sense. One question coming in through live chat is, how do you balance a robust, popular API ecosystem against the risk of cannibalizing your core products?
I think an example here would be helpful.
Andrew, I don't know if you have an example or if you can type that super quickly as to how you're thinking about this, but as soon as we get that, we can jump into like the answer for this one. I'll move on to the next question and we can probably come back after we have an example here. I think one of the ones was around like security and thinking about like thinking about API development and security. And I think the specific question was, in the absence of APIs, there's obviously like like companies scraping your data essentially.
Mhm.
So does it always make sense? Like if you have robots or companies scraping your website for information, is it always a better strategy to have an upgrade to like an API, or like how do you sort of nuance that discussion? Like at what point is your product ready to have an API versus not?
Yeah. So I would think in mainly two different ways. The first one is where your product is something else and your API is there to either unlock new revenue potential. And then the second one is where the product itself is an API. So an example of first would be like Facebook and then Facebook having developer APIs. And the second one could be like Twilio Stripe, where the product itself is an API. So in case of number two, it's if it helps you get more revenue, it obviously helps for you to just expose that API because you can charge for it. In case of use case number one, where your primary product is something else, and then let's say you're sitting on a wealth of information that's being scraped. And then nowadays, like companies have good systems to stop like crawlers and stuff like that. So it's not that without an API, you are exposing yourselves to bots and crawlers. There's a different solution to that. And I feel like introducing API to solve that problem is just conflating different problems.
Makes sense. We got a response from Andrew who was asking about balancing a robust popular API ecosystem against the risk of cannibalizing your core products. I think the example here is Reddit is a good example with Apollo, driving users back to the UI or Reddit app rather than the third-party app to maintain DAU metrics. So what he's talking about is if you offer an API and some third party sort of uses your data to then build a more compelling product, there's always the risk of like your core users sort of going to a third party system and using that data there versus like coming to your core product, paying you the money for it, so on and so forth. So how do you balance
so
those?
the answer to that like depends on the individual business strategy. But in case of Reddit, I don't think there's a lot of information out there as to why they did that. One thing that is super clear with both Reddit and Twitter's example is that now with LLMs, these companies are more protective about their customer data. And with Reddit, like they are just setting on the wealth of information where it's like real humans talking and answering questions. So imagine if you were to create a bot on top of it, it would just be trained on such a rich set of underlying data. And for them to like say that through and curve that, it's sort of like a trade-off where how many users were they actually cannibalizing? We don't know about Reddit's DAO and MAU. And in the absence of Apollo, like I'm not sure how much churn they've had, but that's going to be a case by case trade-off that they would have to do. Like, are those users worth of free access to all of that information?
Yeah, makes sense. One last question, which is more on the technology side of things. I think the question is about like, what are your thoughts around the potential of serverless computing and event-driven architectures in API development? So if you have any tips or ideas about how this space may play out, like that's and touching upon that would be helpful. But obviously, I understand that this is a super technology heavy question. So if you don't have like, if you're not at the center of the space, that's fine too.
Yeah, I would say like ask a PE, ask a principal engineer.
Yeah, makes sense. That was my take when I read the question too. So I think that's perfectly okay. But thank you so much for taking all of these questions and answering them so well. I think this definitely helps our community of PMs understand APIs significantly better. With that, I'll hand it over to Emma to sort of conclude today's session. Once again,
there's one more question in the chat that we didn't go over. The question is from someone anonymous. What is a good amount of time to give before deprecating an API product? So it depends on how many existing customers you have and what is the use case. So for example, in the case of Reddit, like they made API changes overnight. And then, for example, when I was working at Microsoft, we were deprecating this whole suite of developer product. And a good rule of thumb was to like And for a big company, it can take years and years to deprecate something. So a good amount of time could be like 1 year or 2 years, or it could be 6 months, depending on what is the next version, what are your breaking changes. But like some guiding principles here would be who are your existing customers? How are they getting impacted? Have you given them enough time and communicated with them ahead of time with multiple warnings and reminders? And then this period might go for years, and then ultimately you might take a stance saying that, hey, we're gonna shut it down. You have 6 months, either take it or leave it. But it all happens in phases. You don't want to like sabotage your customers overnight. Make sure you give them enough time.
Awesome. Thanks for catching that last one in the chat. Thank you so much for joining us, Archie. I'll hand it over to Emma to conclude today's session.
All right. Yes. Thank you so much, Archie, for the wonderful talk. Thank you, Rishi, as well, for hosting us. And thank you to our audience for tuning in. This will be going live on our website this Friday, so keep an eye out for that as well. Thanks, everyone. All right. Bye.
Bye.